Today, we're going to learn how to write a recursive formula for either an arithmetic or a geometric sequence. And neither are very difficult as long as you realize there's basically three things that are always exactly the same. You should have an AN, which is basically your Y equals. This is your term number. You're going to have an AN minus 1. That is the previous term. So this is a term we're looking for, like the fourth term. And if I plug a 4 here, this means I'm going to take the third term and do something with it. Now, if it's an arithmetic sequence, you're either going to add a common difference or subtract a common difference. So this would be arithmetic when you're adding or subtracting. If it's geometric, you do the same exact thing. You do a sub n equals a sub n minus 1, and we're going to do something with that. But when the geometric, we're timesing by what we call a common ratio, and they use an R for a common ratio. So arithmetic will always look like this. A geometric will always look like this. And the only thing that actually changes from sequence to sequence is this number here and that number there, depending on whether you're adding or subtracting, which that might be a minus sign then, or whether you're multiplying or dividing. Now, in geometric sequences, we don't divide. We always multiply by the reciprocal. So if I was to divide by 3, I would actually put a 1/3 where the R is. Let's do a few examples just to make sure you can get a feel for what we're doing here. I'm going to leave those two right up here. So the first thing we're going to do is we're going to come up with a sequence. So let's come up with some simple sequence: 4, 7, 10, 13, 16. And again, this is a very simple sequence. And first thing you want to do is you want to find, or actually the only thing you need to do is find what your common difference or common ratio is. Since this is an arithmetic sequence, we're going to write this sequence here. And what am I adding every time? I'm adding 3 every time. So all I have to do to write this recursive formula, since it's already given me the first term, by the way, first term, that's supposed to be a 1, by the way. And the second term, we just got to write the recursive formula for it, which would be a sub n equals a sub n minus 1 plus 3. And I'm done. That's the recursive formula for it. Make sure these are subscripts though, right? And that's as simple as an arithmetic recursive formula is. Let's do one more. Let's maybe have it going down. So let's do something like, let's do something interesting. Let's do 10, 9 and 1/2, 9, 8 and 1/2, 8, and so forth and so forth. So this sequence obviously is going down by a half. So it's the same exact thing as we're going to write up here. The only difference is this value right here. We're going to say a sub n, any term, is equal to the previous term. And now what are we doing? We're minusing 1/2. And we're done. We've written the recursive formula for that arithmetic sequence. Now remember, geometric, we're going to be timesing. So let's do a geometric sequence. If I have a geometric sequence, something like, 3, 6, 12, 24, 48, and so forth, all you really need to do is find what am I multiplying going from here to here. And again, it's easy to find by just taking that second term, dividing by the first term, and reducing if possible. I'm multiplying by 2 every time. Times by 2, times by 2, times by 2. So according to our formula here, for geometric, I'm going to write this exact expression, and the only thing I'm going to change is the R value, which for this sequence here is 2. So I go a sub n equals the previous term times 2. And we don't need to put a time symbol there because we know that 2 next to a variable means I'm multiplying. Let's do one more. Let's do something like 81. Hold on one second. Let me think. Yep, 54. 36, 24. Now, I purposely slowed down a little bit on this one because I wanted it to be kind of a difficult sequence. Now, I don't know. It almost looks like we're minusing something. So I go, oh, am I minusing? What would I be minusing? Be minusing 7. 27. I'd minus 27 to go from 81 to 54. But if I minus 27 again, do I get to 36? No, I don't. So I'm not minusing. So let's see if it's a geometric. I must be multiplying or dividing by something to go from 81 to 54. Now remember, if it's hard to see, take that second term and divide it by the first term and then reduce if possible. Well, I can see they're both divisible by 3. So that's going to be 27 on the bottom. Divide this by 3. That's going to be 118, I believe. They're still both divisible by 3. So that's going to be 6 over 9. That's still divisible by 3. That's going to be 2 over 3. So, oh, I am multiplying by 2/3. And if you don't believe me, take the time to multiply 54 by 2/3. You'd get 36. Multiply 36 by 2/3. You'd get 24. So the next one, if I multiplied by 2/3, well, 24 divided by 3 is 8. 8 times 2 is, the next one, 16. The next one would actually end up being a fraction. But remember, all we needed to do was find that common ratio. Now I can write the recursive formula. I'm going to find any term I want by taking the term that came before it and doing what? Timesing by 2/3. I've written the sequence, or that recursive formula, I mean, for that sequence. If you have questions, please bring them to class.